Hello everyone. In this video, let's learn how we can design the circuit for a full adder using two 4x1 multiplexers. So we saw in a previous video the truth table for a full adder is shown here. And then also we use the K-maps to obtain the sum of product form of the sum and the sum of product Boolean expression for the cout. So for more details on how to obtain these expressions, I left the link to the video in the description of this video. So a full adder has three inputs, A, B, and Cn, and it has two outputs, S and Cout. So multiplexers have only one outputs. So since we are required to use two 4-to-1, so let's have one of the outputs be the sum. And then from this multiplexer, we want to produce the Cout. So let's focus on this one first to produce the sum. So next we want to make sure like what do we select for the select ports? We have two select inputs. And then we can choose between A, B, and Cn. Let A and B be our select inputs. So now we want to figure out what will be here in these four inputs. So we can start by building the truth table for it. So we have A and B are select lines. And then here we want to figure out the sum. So for AB, we have four possible combinations, 0, 0, 0, 1, 1, 0, and 1, 1. Now we can use this Boolean expression. Let's rewrite it here. The sum is equal to, so let's see for the first combination for 0, 0. So this will be equal to, we have A is 0, so A bar is 1, multiplied by B bar is 1, multiplied by Cn, plus A bar is 1, multiplied by B is 0, so this will be gone, plus A is 0, so this will be 0, the third term, plus the last term also will be 0. So from this, we'll be left with Cn. So for 0, 0, we will pass Cn to the output, to the sum. So now let's do the same thing for 0, 1. So when A is 0 and B is 1, so A bar is 1 times B bar is 0, so we don't have to continue. This will be 0. Plus, now let's do the second term, this one here. A bar is 1 multiplied by B is 1 multiplied by Cn bar plus A is 0, so this will be gone, plus the last term, we have A is 0, so this will be 0. So now we can get Cn bar. For the second row, we have Cn bar. So next, let's do the same thing for the third row, 1, 0. So A is 1, so A bar is 0. So this term will be 0 plus. A is 1, A bar is 0. The second term will be 0 plus. The third term, A is 1 times B is 0. So B bar is 1 times Cn bar plus. B is 0, so the last term will be 0. So this will be equal to Cn bar. So third row, we will pass Cn bar for 1, 0. For the last row, A is 1 and B is 1. So A bar is 0, we'll have 0 for the first term, plus A bar is 0 here, we'll have 0, plus B bar is 0, so we'll have 0 for the third term, plus the last term, A multiplied by B, 1 multiplied by 1 multiplied by Cn. So the last row, we will have Cn. So let's assume this is Cn input. And to get Cn bar, we need a NOT gate. And the first input is Cn, so we can take Cn from here. The second input is Cn bar, we can take Cn bar from here. The third input is also Cn bar, so that's Cn bar. And then the fourth input is Cn, we can take Cn from here. So now let's do the same thing for Cout. So also for Cout, we can let A and B be our select input ports. So this is A and this is B. So now we're doing the Cout. So let's start by the truth table. We have A and B, and then we want to figure out what we will pass to the Cout. So similarly, We have two select inputs, so we have four possible combinations: 0, 0, 0, 1, 1, 0, and 1, 1. So now we can take this Boolean expression for the cout. So we have cout. So same thing, let's start when A is 0 and B is 0. So when A is 0 and B is 0, the first term will be 0 plus, second term would be 0 plus, this term would be 0. So we will pass 0 to the output, nothing. Now for the second row, when A is 0 and B is 1, so this will be, first term will be 0 because A is 0 plus, second term B is 1 multiplied by Cn plus the last term we have A is 0, so will be 0. So now from this here, we will pass Cn. Now for the third combination, A is 1 and B is 0. So A is 1, we will get Cn plus B is 0, this will be 0 plus the last term will be 0. Also, we will pass Cn. And then for the last row, when A is 1 and B is 1, so we will have Cn or Cn or 1. So we know from Boolean algebra, 1 plus anything is equal to 1. So this will be equal to 1. So now for the last row, we will pass 1. So simply this here will be 0 or ground. The second port, we will bring Cn from here. So I'm just going to write Cn, you know where to get it from. Third is Cn. And the last one is 1 or VCC. So this is how we can design the circuit for a full adder using two 4x1 multiplexers. I hope this was helpful. Thanks for watching.
Enjoyed this video? Subscribe to the Computer Engineering Notebook for more tutorials on computer architecture, embedded systems, and hardware design. And hit the bell to catch the next one.